Hello, everyone. Today we're going to be going over the basics of CAD, such as what it is, why we use it, how we use it. In how we use it, we're going to be going over a few features of CAD, such as extrusions and sketches, just basic things for now. So to get started, let's first talk about what CAD is. CAD, C-A-D, stands for Computer Aided Design. It's usually done through downloaded softwares, and its purpose is, like the name suggests, use a computer 3D model to help you in designing a actual physical part. The reason we use it is it's a lot easier to design something online on a computer where we can tweak numbers and dimensions with just a click of a button. Whereas if we try to do the same thing in person, that can cost us a lot of materials, that can cost us time, and things like that we don't have to spare. So CAD is just a useful tool to prepare for actual manufacturing. So let's start off and see what the software looks like and how to work with it. In our team, we're going to be using this software called SolidWorks. Um, it's a really efficient tool and it works well with teams. So first, let's click this part button. To get to this screen, you should click this right here. This will give you a new document screen, and then you can choose between these three documents. For now, only worry about parts. We'll go over assemblies in the next lesson. So click OK. And now here we have it, our SolidWorks screen. So our SolidWorks main screen has three separate sections. Four actually, but three that you have to worry about. First, we have this on the side. This will show you all of the features or parts on your design. So for example, right now, since we haven't added anything, all we have is these planes. And if we go into the specifics, it'll show you some like this placement of this of these axes. It'll show you things like that. But this is going to be more important once we start having actual parts. Then we have this big blue area right here. This blue area is where you can see any parts that you make. This is where you're going to be making all the edits to your part and how you can visualize the model that you're trying to make in real life. Then on the top here, this is our toolbar. This is where all of our tools to edit or create our parts are going to be. So the two main tools that you're going to use for now is this sketch toolbar, which has all of these, and this features toolbar. We'll go over the important features that you need for now in a moment. First, let's talk about the difference between a sketch and an actual feature. So a sketch is what you start off with before you make a part. Think of it like this. A sketch is the two-dimensional face of a part. So if you were to take a part, look at it from one side such that you can only see that side, the visual diagram that you'd see on that side would be your sketch. So for example, if I were trying to make a sphere, the sketch would be a circle, because if I look at a sphere flattened out on one side, then all I would see is a circle. If I were trying to make a cylinder, then the side view could either be a circle or a rectangle, depending on which side I look at. So we're going to start off this demonstration with two different pieces. One is a tube stock. Tube stock are the big metal beams on our robot. They're the foundational core pieces of our robot. They're what hold everything together, and they're the main structure of the robot. The second piece we're going to work on today is called a gusset. A gusset is what holds together these foundational pieces of the tube stock, as well as sometimes some other smaller pieces as well. So first, let's start off with learning the sketch tool. For the sketch tool, you have to select what plane you're working on. The plane, again, just shows you how your part is facing. So when you're making a first sketch, it doesn't usually matter, but I like to either go with front or top, just because those are the easiest to work with. For now, let's go with the front face. So these are the features on a sketch. Right here are the things you can draw. Think of this a little like Microsoft Paint. You have different shapes that you can draw anywhere, and you can fill those in. These are also some tools that are important. We'll get into these in a minute as well. These are how to transform what you draw and make something out of it. And then over here is the dimensioning. This is how you define what you draw. So definition in terms of CAD means making something so that it can't change. For example, if I have a piece of metal in my hand, if I try to pull on it, I can make it move around because my hands aren't stuck in one spot, right? I can move it, but I can't pull on it. However, if I screw that same metal into something that's not moving, and I try to move that metal, now the metal won't stretch, it won't shrink or move. So consider that what define means. Like, it just means that it can't move, it's solitary, it's stable. So these are the three main sketch sections that you guys are going to be working with. Just again, a review. This is modifying your sketches. This is creating the main features of your sketches. And this is defining your sketches. So let's start off with the rectangle tool. It's pretty simple. You just place a point. I always like to start off in the origin. It's usually a good design practice just to start all of your pieces on the origin. And then, so you click one corner of your rectangle, and then it picks the opposite corner of your rectangle, and you have to place that one. So place that there. Right now, this rectangle is made with completely random side lengths, right? So now if I want to define that, we go here to the dimension tool. We click either the whole leg. So if I click this, it'll select that whole side length of the rectangle and highlight it. This way I can go in and dimension it. For now, let's put this at 1 inch. And then next, we can go to this top side and dimension that one as well. But instead of trying to highlight this, let's see another way we can do this. We can click both of the edges that it's between. So, for example, this dot and this dot, so the corners of the line. Or we can select these two side lengths and define the distance between those, because that's what the top of a rectangle is, right? It's just the distance from which these two lines are separated. So let's put that there and put in 2 inches. Now we have a fully defined rectangle. How do we know this? Well, in the bottom over here, SolidWorks tells us that this piece is fully defined. That is the first piece you've made. So I'll just show you how a couple other of these pieces work. We'll go into circles in a moment. Lines are pretty simple. You just draw a point, draw another point. Again, this is a lot similar to Microsoft Paint. So I'm just going to delete that line now. To delete anything, you click it, and then you right-click it, and then you scroll down here to delete. Now, for my piece of tube stock, I want another rectangle in here that's the same as this rectangle, but all of its sides are offset by 0.1 inches. Rather than having to draw a rectangle here and like inside, like that, and dimension all of its sides, what I can do after I delete this is I can use this offset entities tool. This is one of our modification tools. What it does is it takes any entity or shape that you have, and you can either extend it, or extend as in make it bigger and go outside, or you can make it smaller and shrink and go inside, but it'll retain its same geometric properties. For example, a rectangle if you try to offset entities it, you can either make it a bigger or smaller rectangle that maintains the same center point, but everything else can change. So the dimensions of it can change. The side ratios are also going to stay the same. So it's always going to be a 1:2 or a 2:4 or a 3:6 rectangle. So let's try it with this one. If I click this, it selects the whole rectangle for me. Right now it's making it bigger because that's its default. SolidWorks defaults to making things bigger. I want to reverse it. So either I can click this reverse button, or before doing that, I can also, this yellow arrow indicates which way your part is offsetting. So right now it's defaulted to the left, so increasing, but I can click this right here when it's pointing to the right, and it's going to shift it inwards. And that just made the offsetted left rectangle. So the offset is like we wanted, 0.1. If we wanted it differently, what we can do is we can double click this and say we wanted a 0.25 offset. We just type in 0.25 and it changes the offset for us. But we want 0.1, so we can go back in, type in 0.1 inches, and there we go. We have our sketch. Now that we have a piece of sketch, or we have a design in our sketch mode, how do we make it into a physical, complete design? For that, what we have to do is click this button to exit our sketch mode. So we have to exit this tool. Then we have to go to the Features toolbar and click this button, Extruded Boss/Base. So this button, what it does is it extrudes any piece. And extrusion is basically taking a flat face and pulling it out. So consider you had a piece of, I don't know, Play-Doh or slime, and you pulled it out in the same dimensions. It would just keep going in that direction, right? So it's something similar here. Let me show you guys. So if I click extrude, watch as this piece just keeps growing in the same exact geometric pattern. So we can make it bigger, smaller, however we want it to move. First, let's give it an actual dimension, because while we can move it with an arrow, it's usually far more convenient to just type in the number that you want. So 30 inches. Here we are. We have a piece that is 30 inches long. If we click this check mark, then we'll see we have a fully extruded piece of tube stock. So we went from a flat sketch of this face to that piece using the extrude tool, completely extruded. So now it's a 3-dimensional model rather than a 2-dimensional sketch. Another feature our tube stock has is a hole on these shorter faces. So by the 1-inch by 30-inch face. And it's going to have it on this side and on this side. So to change a part or add more features to a part, what we can do is go back to our sketch tool, click this create a new sketch button, and then select the face that we want to add a feature to. So since we want this 1 by 30 face, we click that face. And then since we want a circular hole, what we can do is click circle, make a circle right there. The circular tool, what it does, you can place down a circle anywhere, and then later on you can go in and give it a dimension for its radius and its position. So it just places down the center, and then you can drag it out to get its radius. So now let's dimension this circle. For this model, we want our dimension to be 0.2 as the diameter. So when we dimension our circle, it usually gives us diameters instead of radii. So we can go here, 0.2. So now our circle has a diameter of 0.2, but it's still underdefined, as we can see down here. That's because its position isn't currently defined, so it can move anywhere across this face. Let's change that. Let's give this a dimension, 0.5, and this a dimension, also 0.5. Now, our circle is fully defined. But we want one circle going across this whole piece of tube stock. So at every 1 inch. So rather than making 30 different circles, what we can do is we can use a thing called a pattern. So there's different kinds of patterns. This again is one of the modification tools. For these patterns, we have two options. One, we can make these patterns on our sketch. So if we make it on our sketch, that I can show you guys right now, but it will create a little bit of a problem later on. Let's see why. So first, let's look at how to make a pattern. There's 3 different prompts that it asks. So one is the direction. So since we want our pattern to extend across this length, we select a leg or a line that goes in the same general direction. So for example, this one. It also asks for a secondary dimension because with the linear sketch pattern, what you can do is you can make a pattern in a rectangular shape. So for example, if you look here, the blue pieces, what they're patterning can go up and down. But for now, we only want it going in one direction, so we don't have to give it this direction. And then you have to select what entity to pattern. So that's what feature you want to copy and paste everywhere. For us, it's the circle. And then if we can scroll back up here, there's 2 more boxes that we have to fill in. One is this dimension. This one is how much distance there is in between each circle. So, or in between each instance of whatever you're patterning. For in this case, it's a circle. So we want the spacing to be 1 inch. So look, it created a copy of our part 1 inch away in that direction. And then this box is how many of them we want. So right now, there's currently 2 copies of them. In our situation, we want 30 copies of them. So now our whole tube stock is covered by these circles. Perfect. We can now click this green check mark to complete that. And now we have a full sketch for our holes. So again, to now delete, we have to go to our features. So we can click exit sketch, then click features. And now instead of extruding, we go with the extruded cut tool. The extruded cut tool is identical to the extrude tool, but rather than adding material, it takes material away in, again, the same geometric shape. So click extruded cut. And now here's the issue. When I click sketch and click extruded cut, in some softwares, it won't actually select all of your circles. So what will happen is in your extruded cut, it'll just select this one right here, the first circle that you selected, and then you'll have to go through and select every single one of your circles. So in this case, it worked out for us. It's selecting all of our circles, but it's frequently the case that it doesn't. So I'll show you guys the other way of doing it as well. Now, one way of cutting through our whole piece is either just giving it a huge dimension so that it just goes through, or since we know exactly where we want it to go to, which is right there, we can either give the distance from here to here, which we know to be 2 inches because that's how we made the part. So if we make this 2 inches, it will go exactly till this face. Or another way to do it, and by the way, if you want to edit any features that you ever make, you can go to the left here. This is where you see all your features. Left click the feature, and then click this button right here. This is for editing your feature. The other way to achieve this specific positioning, in the case that you don't know the dimension of your part, is you can go here. You can either go through all, in which case it goes through any piece of material that's in front of it, regardless of how far it is and what it is. That's one way of doing that. And then there's a third way of doing it. Again, going back to edit feature, we can do up to surface. What this does is you provide a specific position that you want it to go to, and it cuts everything until there, but no further. So it's like giving it a dimension, but instead of like a distance, you're telling it where to stop. You're just giving it its finish line. So for example, our finish line is this face. So we click that. Now the holes are reaching all the way there and no further. So that's how you get the holes with a sketch pattern. Now I'm going to delete a little bit of our progress so that we can see how to get the holes without the sketch pattern. So I'm going to go through, delete all of those holes. So I'm going to go back into our pattern and make this from 30 to 1. That's now gone and deleted our holes. These yellow circles are an indicator of your past edit. So what it does is SolidWorks shows you everything that you've changed one edit prior to what you're doing right now, just in case something is a mistake and you can find out what you just did. So these yellow circles aren't actually there. It's just an image of history, basically. So now that we have this one hole, we can exit sketch. And since we had already extruded it, it's gone through completely. From this point now, we can, instead of making the circular sketch a linear pattern, what we can do is we can make this 3-dimensional cylindrical hole pattern. So how we do that is, instead of making a pattern in the sketch, this linear sketch pattern, we can do the same thing in features. So we can make a linear pattern of features instead of a sketch. So identical to how we do sketch patterns, you have to select your direction. So we want it to go along this axis. You have to select your feature or face. For us, it's features, not faces. You have to go inside the hole, select that. And then you have to figure out how many you want and where you want them. So for us, we want 1-inch spacing. And we want 30 of these pieces. So click confirm. And there we go. We got the same result as we did in sketches, but it was somewhat more efficient. So that is our piece of tube stock. Congratulations. If you've been following along so far, you have just completed your first CAD model. Now, like I said earlier, we are going to work on making a gusset. All right, so here is what our gusset looks like. Right there. That's the gusset. To make this, we'll be learning 2 to 3 new skills. 1, we'll see how to use our pattern in a different position. So instead of just doing it in one line, we'll make the pattern so that we have to go 2 ways now instead of 1. Second, we're going to learn about the fillet and chamfer tools. The fillet tool is what you get to get this rounded edge, and the chamfer is what you get to get this cut off right here. And the third and very important tool or method that we're going to learn about is how to look at an engineering drawing and decipher what it means. So let me zoom into this a little bit so that you guys can see it a little easier. But here is what our drawing looks like. This is an engineering drawing, and it has one face right here, another face right here, and the 3D model right there. What it does is it provides you all of the information you need to make the part. So whenever you make a part, if you make an engineering drawing of it and send it to someone else, they should be able to look at that drawing and make a part that's identical to the one you made and be able to replicate it. So let's see how to do this. First, let's make the simple shapes in our part. If we look at it here, it's kind of like an L shape, which is 2.74 by 2.74. So let's go to SolidWorks, create a new part. Oh, and look what SolidWorks is reminding me. I should save my document. And this is very important. After every major edit you make sure to save your document. And name your document something that's memorable, because SolidWorks will always just call your documents part 1, part 2, part 3, part 4, and so on. For us, let's have a good naming structure. So since this is a 30-inch gusset, or a 30-inch tube stock, we can say tube stock 30. And now let's make a new part for our gusset. So again, we click this button for new features, new documents, and then we click this part button. Click OK. There we go. It's the screen we love again. Let's go into Sketch, create a sketch, and go here on the top plane. Once here, let's make that L shape we saw using the line tool. So again, it's literally Microsoft Paint. You just plop down lines, draw whatever you want. There we go. So now we have the basic shape of our part. Let's get down to specifics now. So we select the dimensions that we want. This was 2.74. And this was 2.74. And so once we get these dimensions in, we can now start getting this more smaller dimensions. So for example, the dimensions for this, the dimensions for the side cutoffs, the dimensions for the rounded edges. So let's look for that. Let's go to our drawing. Our sides dimensions aren't specifically given. So we have that this is 1.39, but that's after looking at the fillet. What we do know, though, is that this side is equal to this side, and that these cutoffs are 1 inch in length. We know that our holes are in these placements, so we can still get a part identical to what we wanted. It's just that the order of operations is going to be slightly different. So first, what we should do is we should go in and make our part's rounded edge. So to make a rounded edge, what we do is we use this fillet tool. A fillet is, again, like I said, it's just taking a point and filling in that area a little bit. It's filling it in a little bit. Dad jokes. But in this case, it's filling it in. For example, if I tried to cut this part off, if I wanted to make a rounded edge here, it's actually cutting something off. So basically what it does is it rounds off any sharp edges you have. Now comes the question, why do we use this? Is it just because we prefer round shapes? Well, technically, yes. The tool we use to process any piece that we make is called a CNC. A CNC machine has a sharp, kind of like a drill bit at the end of it. It's not a drill bit, but it's somewhat similar. And that just spins really, really fast. And it creates bores and it like digs into your piece really fast. So if it's trying to make your piece and trying to cut it out of a sheet of metal, then it can't make a angular joint. So it can't have this intersection right there, that 90 degrees, just because, again, the piece is a kind of like a drill bit, which is rounded. So if you're spinning that really fast, you can get close to an angle, but you can't get that precise 90 degrees, and you have to give it a slight rounded edge, or else we literally cannot manufacture that part. So that's why we use a fillet. Let's see how to work with one. So our fillet has a 0.35 distance. Rather than giving us the radius of this fillet, we have this distance right here. So what we can do to work with that is, that's an interesting piece. If we make our fillet right there, for now, let's assume that the fillet, okay, you know what? Cut that a little bit. Yeah. Cut, 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 cut. So that's why we use a fillet. But now let's see how to use the fillet. So this sketch is a little off because it has this dimension wrong. So this is actually supposed to be a 0.35 radius fillet, instead of this distance being 0.35. So sorry about that sketch, but sorry, this drawing, but ignore that real quick. So we have this being 0.35. Let's go in with our fillet right there. So we have to just click this point where we're filleting, and then we can put in our dimension. So our dimension, again, like I just said, is 0.35. And click this check mark. So there we go. We have the shape of the fillet done. And now we can make these sides dimensioned. So these are 1 inches, 1 inch sides. So we give that one 1 inch and that one 1 inch. For anyone who's confused on how I knew this is 1 inch, we have this length given as 0.8, and this one is 0.1, and this one is 0.1, since these two are identical. So just 0.8 plus 0.1 plus 0.1, that gives us 1 inch. So now we have the rough shape of our part done. We can now add our chamfers. Chamfers are what we use to cut off the sides or the angles of our edges. The reason we use those is mainly just to avoid sharp edges, and it isn't specific for manufacturing. That's a little bit more on appearance and functionality. So chamfers, you have multiple options, but for this one, we're just going to use a distance chamfer with an equal distance. Don't worry about what those mean right now. That's not that important. So our distance is 0.1. So we type that in for the dimension. And then now we go to where we want our chamfers. So we select there, 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 and there. Click that green check mark. And there we go. We have our chamfers made. So now we have one thing left to do, and that is to make our holes. So we can draw our circle here. Again, identical to how we did it before. Make this 0.2. Give it the dimensions that it needs. That might be 0.5. That looks better, yeah. Give it that dimension. Same thing from this side. And then the only thing we have left to do is pattern the circle. So we go to our sketch pattern, linear sketch pattern. Completely identical to how we did it before. We select one axis that we want to use. So for right now, it's this one. Second one, we don't have to worry about because we aren't making a rectangle. If we were to select both axes, what it would do is make a grid of the circles. Let me show you how that would look. So if we have a second axis here, and we have our entity selected, if we do both axes, it makes a rectangular grid of those parts. Increase the distance so you guys can see it a little better, like that. However, we just want these outlying lines. So for those, what we can do is we can just use two patterns. So first we do it once here, and then once we do it here. So click the pattern, click the line that you want it to follow, and then click the instance. So now notice that this circle is going towards the left. We want it to go to the right. What we can do is click this button right here, these two arrows. What that does is it flips the direction. So now it's going to go to the right. Plug in our spacing, 0.5 inches. And plug in how many we want. We want 5. There we go. We have our first one. Now let's go through and do that again for our second one. So we select the axis that we want, this one. We select the entity that we want, this one. It's still extruding in this one just because we have two instances there and one here. So it's only creating it in this way. So what we can do is we can reduce the X instances to 1. That makes it so that it's not going that way. And then now to go down, we can increase the Y instances. So we want 5 instances at a distance of 0.5. So just confirm that. And there we go. We have the top-down view of our sketch, of our gusset. So now we can go through, extrude it. Let's see how much we need it to be extruded. It says 0.09 inches. So let's go do that. The extruded base. Type in 0.09. And we are done. Now we're done. So good job today. Today we worked on making a gusset and a tube stock. Throughout that process, we learned about various tools. First, we learned about how to use a sketch and an extrusion. Then we learned how to make patterns, how to make specific features on sketches, on pre-made parts, and so on. Furthermore, we learned in the beginning what CAD itself is, why we use it, how effective of a tool it is. And we learned about the general interface of SolidWorks. Thank you for watching, and feel free to contact me if you have any questions.